China didn't stop to wonder if that was possible. It simply made it real. This is the Gupitan Shiplift, a $7.70 billion megalevator built to carry 11,000-ton ships. SH1 as tall as a 66-story skyscraper, straight up the face of a mountain. A staggering vertical climb of 653 feet, like a floating giant, daring gravity to fight back. But why would anyone build something so extreme? Because this wasn't just about moving cargo. It was about rewriting geography itself. China's inland trade has always faced a brutal enemy: mountains, cliffs, and wild, unpredictable terrain. Rivers twist through stone-like scars, and roads cling to cliffs as if afraid to let go. And before we go further, don't forget to like and subscribe to our channel. Nowhere is this challenge more obvious than along the Wujiang River in Guizhou Province, a place where transport was once slow, expensive, and often deadly. This isn't just rough terrain. It's hostile terrain. Jagged limestone peaks erupt from the ground like dragon's teeth. Narrow valleys drop hundreds of feet into shadow. Monsoon rains turn gentle streams into violent floods. For centuries, people called this region the mountain that devours men, because its landslides, cliffs, and collapsing paths claimed countless lives. Before the shiplift existed, moving cargo through this stone maze was nearly impossible. Ships couldn't pass. Trucks crawled along fragile mountain roads, constantly threatened by falling rock and mud. Traditional canal locks used successfully in flatter regions were useless here. To climb nearly 656 feet using standard locks would require at least 20 separate chambers, making transport painfully slow and absurdly expensive. Sending a single container from Guizhou to Shanghai could take up to 2 weeks and cost 3 times more than similar routes elsewhere in China. Local businesses struggled. Foreign investors stayed away. An entire province of 36 million people, larger than many European countries, was trapped in economic isolation inside one of the fastest-growing economies on Earth. So, China chose a different path. Instead of forcing the river to bend to commerce, it made commerce rise with the river. That's where the Gupitan Shiplift changes everything. This machine crushes for days of travel into just 2.5 hours. Picture a ship as long as a football field gliding into a massive steel chamber. The doors close precision-engineered hydraulic gates, each weighing 440 tons. Then the transformation begins. Giant pumps thunder to life, flooding the chamber and lifting the ship on a cushion of water, turning the entire structure into a liquid elevator. The chamber alone weighs 3,300 tons when empty. Add water and a fully loaded ship, and the total mass exceeds 12,100 tons. And yet, it rises. Slowly, smoothly, the whole structure climbs straight upward, like the river itself is standing up and carrying the ship over the mountain. The vessel ascends higher than the Statue of Liberty and the Great Pyramid of Giza combined. Inside the ship, the moment feels unreal. The ground slips away. Valleys shrink into lines. Through narrow windows in the chamber walls, passengers watch the world fall downward as they rise into the sky. The river becomes a ribbon. Villages become dots. The immensity of the mountains only reveals itself when you are already halfway up their towering slopes. When the chamber reaches the upper reservoir, the front gates open to reveal a new world. A vast lake where, minutes earlier, there was only air. The ship glides forward and continues its journey as if it hadn't just performed a miracle of engineering. It's not just a shortcut, it's a revolution. A river highway carved into the sky. At the heart of this machine is a floating fortress. A Colossal chamber 131 feet long and 39 feet wide, holding 550 tons of steel and water. But how do you lift something that massive without disaster? The answer lies in raw mechanical force and surgical precision. The chamber moves along for gigantic concrete towers that act as guide rails and structural support. These towers are anchored deep into the rock, with foundations extending 230 feet below the visible structure. Each tower contains redundant systems of cables, counterweights, and emergency brakes. There are 256 steel cables, each strong enough to tow a jumbo jet, guiding the chamber through a vertical gear system. These are no ordinary cables. Each one is made of 127 individual strands of high-strength steel, twisted in a precise pattern that maximizes strength and minimizes weight. Laid end-to-end, they would stretch more than 50 miles. Interlocking metal teeth lift the entire structure vertically, like a gear the size of a skyscraper. These teeth must mesh perfectly every cycle, with tolerances measured in fractions of an inch, despite the enormous forces involved. They are made from a special alloy extremely hard, yet flexible enough to absorb microvibrations that could damage the system. A safety system with massive nut columns absorbs violent shocks from wind, waves, and even earthquakes. The lift must remain perfectly balanced, even under the tremendous weight of ships and the turbulent pressure of water. Sensors throughout the structure constantly monitor any imbalance, automatically adjusting the mechanism. Counterweights and hydraulic dampers help stabilize the motion, ensuring that even with inch-level precision, the system does not yield under pressure. The dampers contain enough fluid to fill an Olympic-sized swimming pool and can absorb forces equivalent to the impact of a small meteorite. Energy consumption is enormous. The lift uses enough electricity to power a small city, although much of it comes from the dam's own hydroelectric turbines. Backup generators can supply emergency power to safely lower the chamber in case of grid failure. Each cycle is a higher-risk ballet between physics and engineering. One miscalculation, and the entire 11,000-ton mass could slam into the structure catastrophically. The control systems have 5-layer redundancy. 5 computers constantly cross-check each other's calculations, and any discrepancy instantly triggers a safety protocol. Each lifting cycle takes only 30 minutes. In 2.5 hours, an entire mountain chain is bypassed. The system can perform up to 24 full cycles per day, moving nearly 5 million tons of cargo per year. A colossal shortcut, a turning point for China's trade routes, but efficiency wasn't the only goal. This project had a much bigger agenda. At first glance, the Gupatan shiplift looks like just a futuristic way to move cargo. But beneath the surface, it reveals a far deeper strategy that redraws China's economic map. For decades, Guizhou province was a logistical desert. Its economy was trapped by the same mountains that made transport nearly impossible. Industries struggled. Trade crawled. Entire regions were cut off from prosperity. The province ranked among the poorest in China, with GDP per capita less than 1/3 that of coastal regions. Now that has changed. With this vertical water highway, Guizhou is directly connected to China's economic backbone, the Yangtze River. The result, a 5 million ton cargo corridor that cuts costs, speeds up trade, and transforms a forgotten region into a vital economic hub. The numbers tell the story. Since the lift was completed, transport costs from Guizhou have dropped 67%. Industrial output has increased 42%. Foreign investment has surged 83%. Sectors once impossible, from advanced manufacturing to large-scale agriculture, have become viable. A province once known for subsistence farming now hosts tech parks and export zones. Villages that barely survived now thrive as service centers for the new logistics corridor. Thousands of jobs have been created not only in transport, but in maintenance, logistics, and support sectors. Tourism has also grown, with the lift becoming an attraction for national and international visitors, fascinated by this engineering wonder. But there's a bigger picture. This isn't just about regional development, it's about strengthening China's internal supply chains. Imagine if international routes were disrupted. Ports close. Sanctions tighten. Global trade stops. How does China keep its economy running? That's where massive internal infrastructure comes in. The Gupatan lift is part of a larger network that includes the Three Gorges Dam, the south-to-north water transfer project, and thousands of miles of inland waterways. Together, they form an internal circulation system capable of keeping goods flowing, even if external arteries are cut. This isn't speculation. China's dual circulation economic policy explicitly prioritizes resilient internal chains that can function independently if needed. Projects like the Gupatan lift are physical manifestations of that strategy. While the world focuses on Chinese skyscrapers, bullet trains, and megacities, it's the hidden networks buried in mountains and rivers that may define its future. These projects get less international attention, but they may be the most decisive. The lift also represents a powerful geoengineering approach to climate adaptation. As the climate becomes more extreme, water control becomes vital. Systems like the Gupatan lift help regulate flow, prevent flooding, and keep navigation possible despite changing rainfall patterns. This lift is not just a machine. It's an insurance policy, a chess move in the global economic game, a physical expression of China's long-term strategic thinking. Was it built for efficiency or to protect China's future against global uncertainty? More and more, the answer seems to be both. The Gupatan shiplift is not just an engineering marvel, it is a statement. A $7.70 billion vertical highway that bends mountains to its will, shortens trade routes, and reshapes entire regions. But it is only one piece of a much larger puzzle. Similar projects are already under construction across western China. The technology developed at Gupatan is being refined, scaled, and expanded. Future lifts may be even taller, faster, and more efficient. And this expertise is becoming an export product. Chinese engineers who worked on Gupatan now consult on similar projects in Southeast Asia, Central Asia, and Africa, as part of the Belt and Road Initiative. Knowledge gained from one impossible project fuels dozens of others. If China could do this, what comes next? Because while the world watches its skyscrapers rise and its bullet trains blur past, it's what happens beneath the surface, the hidden infrastructure that could change everything. And if this is only part of a bigger plan, how far is China willing to go? Tell us what you think in the comments. If you enjoyed this video, subscribe and watch our upcoming videos.